Okay. All right. Cool. So this is a really great way. A lot of people, we get a lot of questions around how do I get started with Presto? What's the best way to kind of join the project and start, collaborating with other folks? This is a really good way to do that. Join a working group and meet more people in the project that are working on specific areas and get kind of your feet wet in terms of getting more involved and contributing back to the project. All right. So with that, today's talks, what it should say. We have two. So first, very excited to share our Presto O'Reilly book is done. We've completed it. It is a full book all about how to learn, all about learning and operating Presto. So I am very excited to have three of our authors here. We have Tim, we have Angelica, and we have Vivek. These three, along with Yang, who couldn't be here today, put a lot of time and energy into making this book a really awesome piece of content for people to learn Presto, get up to speed, and to get it operating at pretty significant scale. So I've invited them to talk a little bit more about the book, and why it's important and what it's about. This is a great time to ask questions of these folks. These are like Presto experts. And so they are a resource to you, especially during this call. If you have questions, now's the time to ask. And I'm going to ask them to kind of talk a little bit more about that book. And I will also, after this, put a link in. It's free right now. The ebook is free to download. It's sponsored by IBM, so compliments to IBM. If you fill out a form, you'll get the book for free, and I'll put that link in there again. Following that, we have Beinan and Hope here from Alluxio, and they're going to take us into Presto caching, deep dive into that. Okay, without further ado, I'm going to pass things over to Angelica, who is going to get us started with learning more about the Presto O'Reilly ebook. So Angelica, please take it away. And you're muted, Angelica.
Just a moment that I share my screen, because okay. Can you see something?
Yep.
Okay. Okay. Hi to everybody. I'm really excited to be here today with you. For me, it's the first time I'm here in this meetup. And in these slides, I present shortly the book, Learning and Operating Presto. But before that, I'd like to share something about me, because probably you don't know me, and I'd like to share something. My name's Angelica Duca. I am, just a moment that maybe you can see. Okay. I am a researcher at the Institute of Informatics and Telematics of the National Research Council in Italy. And my research area, focus area, are everything around the data, with a focus especially on data science and data storytelling, data engineering, with everything related to data management, data storage, and so also Presto. And I also study web applications and recently generative AI. I am also an adjunct professor of data journalism at the University of Pisa, and the authors of the book AI-Powered Data Storytelling in Python with Altair by Manning, Comet for Data Science by Pact, and the co-author of the book Learning and Operating Presto by O'Reilly Media. I'm also a contributor at some of the most popular data science publications, Towards Data Science, KD Nuggets, and datatalks.club. And if you want, you can read my blog posts and my news about me in my blog, elod83.medium.com. Now that I have said something about me, we can move to the book, to a deep dive into the book. First, this book is the result of a joint effort between an industrial background and an academic background. This industrial background was provided by my co-authors, Tim, Vivek, and Yang, who describe in the book how to operate Presto to build a secure and scalable architecture. They bring their competencies to the book to describe this part. From my point of view, instead, I bring to the book the academic background, which explains how to learn Presto, which explains how some details about learning Presto and the data lakehouse landscape. And here you can see also the title of the book, which is Learning and Operating Presto. Throughout the book, you will learn, we will have a progressive learn. We adopt a progressive learning approach. First, you learn the basic concepts, and you will learn everything gradually. First, you will build a basic system, and then you will add a new component or new components chapter after chapter. This means that each chapter is a standalone, in each chapter you will build a system which is a standalone object you can use for your purposes, so you can enrich in the next chapters. The book is composed of two main sections. The first section is Getting Started, which involves chapter 1 to 4, and the second section is composed by the core chapters 5 to 9. In the first chapters, in the first 4 chapters, you will learn how to get started with the Presto, how to configure a basic cluster in Presto, and also how to run it, how to deploy it in your local machine. In particular, you will learn in chapter 1 an introduction to Presto with the Presto origins and also the Presto architecture. And in chapter 2, you will learn how to get started with Presto. You will learn how to install Presto on Docker or on Kubernetes. At the end of chapter 2, you will be able to install and deploy your local cluster with 1, 2, or more Presto nodes, with a single coordinator and many workers. Then, in chapter 3, you will learn how to connect your Presto cluster to external sources with a focus on connectors. In particular, you will see popular connectors, but the book doesn't give many details on these connectors because you can find them already in the Presto documentation. Instead, in this chapter, you will focus on thrift. You will implement a use case using the thrift connector, which is more tricky as a connector, and also how to deploy and how to implement a custom connector in Java. This is a very interesting part, which usually you don't find in other books or in the classical documentation. Here you have a complete example in Java. Next, the next part is chapter 4, where once you have set up your cluster with your catalogs, you learn how to connect a client to your cluster. And in particular, you will see different types of clients. You will build a client based on the REST API in Python, in R, in JDBC, in Node.js, and in ODBC. Obviously, you can filter only the clients you are interested in. For example, if you use Python, you can jump the other sections and only read the part related to Python. Here you have some ready-to-run code, and so you can directly use it. At the end of these four chapters, you will be able to deploy a complete, simple Presto cluster with your cluster with your coordinator and your workers and the connectors and also clients. To complete the chapter, you will build a practical use case, a practical scenario with a Python client which connects to Presto to query a TPCH catalog to retrieve some information and build a dashboard. This is you will have, at the end of the 4 chapters, you will have learned all this stuff. Then you will move to the core chapters from 5 to 9, which contain detailed and advanced information to transform your simple Presto cluster into a secure, scalable, and performance-tuned cluster. You start in chapter 5 with the Open Data Lakehouse analytics. In particular, you will learn some theoretical concepts related to data lakehouse, and also you'll implement a practical scenario where you have your Presto, which is the query engine of your data lakehouse, with your Presto client that you have already implemented in the previous chapters. Then you will enrich your cluster with a connection to a Hive metastore. And so in this chapter, you learn how to add the metadata catalog to your cluster. And you also connect everything to an object store. In this particular case, we will use Meehan. And we will store all the information in Hoodie. So you can see here also we will implement a Meehan client, okay? And here you can see that we are using some of the most popular technologies such as Hive and Hoodie. To write everything in Hoodie, we will use in the book, we will use Spark. And this is a very complete example to build a simple lakehouse scenario. In the next chapters, you'll move on and you will learn how to administer Presto, use in particular how to configure, monitor, and manage it with different techniques. In chapter 7, we will focus on security aspects in Presto, such as how to establish a secure communication, how to perform authentication with some different techniques, including file-based authentication, LDAP, and Kerberos, and how to perform authorization in Presto using access control and also a focus with the Apache Ranger. And in chapter 8, you will move to performance tuning with the focus on the query execution model, area scan. And at the end of this chapter, you will have also a practical example that you can implement. Finally, in chapter 9, the last chapter, you will learn how to operate Presto at scale with some design considerations to take into account to build a system at scale, how to work with multiple coordinators, and also how to run Presto on Spark, and how to perform spilling in Presto. Finally, also the option to use a cloud service to run your Presto cluster. All this stuff discussed and described in the book, we produce obviously some code, and the code of all the code implemented throughout the book is available in the GitHub repository of the book, which contains chapter by chapter complete and standalone codes that you can use for your purposes. For example, if you want to install a data lake house, you can take the code in chapter 5 and you can deploy directly in your local machine or in different machines if you want. That's all for the book. Thank you very much for your attention. You can reach me on LinkedIn, or you can drop me an email if you want to connect with me, or if you have questions, you can ask now.
Thanks, Angelica. I think that's an awesome overview. So hopefully for folks that were not familiar, this kind of gave you some pretty solid context on what the book was about. I'm going to turn it over to Tim, who also was a co-author on this, just to maybe, Tim, you can talk a little bit more about, why we even wrote this book and why this might be an important thing, for the Presto open source community.
Yeah. And I think that I'm really excited that, this is released and available. And I think it's really necessary because, of course, like what this does is it gives you a whole lot of context all in one place. And, like deploying Presto and operating Presto, it strives to be easy, but it is a complex undertaking. And so without, and oftentimes when one approaches kind of like big data tools, it's sometimes difficult to get the total context needed to go about it successfully. And so there's technical documentation, but the technical documentation's emphasis is on completeness, and it's not on, kind of like getting that context and having that larger picture necessary to control and operate it successfully. So that's where this book fills in. The book kind of like gives you just an overview of the landscape. There's like some really great documentation on how to get going with it. How, some example connectors that kind of like give you a sense of, how this could be useful for your internal deployments. And then also kind of like the overview on how to operate it. And even that's a very large undertaking. And what it gives you is kind of like it sets you up for success in that endeavor, because it gives you, a lot of really helpful tips and context needed to go about that really successfully. So, and there's also kind of like a lot of other things that probably you haven't even thought about. So like, typically you approach these problems wanting to solve a particular problem, but you don't, what this book gives you also is kind of like those second order things that are also quite important, like security and performance and stuff like that. So really excited for this book, and I think that this is going to be a great addition to the community, and I hope that it'll be a really terrific resource for for those who are kind of like just beginning on their Presto journey, or even if you've been operating it for a while. I think that there's kind of like it's useful to have it just so that you have kind of like at your fingertips all that context and knowledge in one place.
Thanks, Tim. And then Vivek, I'll turn it over to you as another co-author. I mean, you've been working on this book for a long time, Vivek. You have a ton of experience and perspective, I think, on running Presto at pretty massive scale at Uber and, now at IBM. So what's your kind of, how did your experiences kind of help shape this book, and what's your perspective on that?
Sure. Hey, folks. So I first started working with Presto about 5 years back, right, at Uber. Prior to that, I come from the traditional data warehousing space, right, where you have an enterprise software company shipping software bits, which a customer buys. They also hire a DBA to help them manage their databases, right? Presto was kind of intended as an alternative to this model, right, where it was supposed to be a piece of software that anybody could adopt and use. Um, but over the years, the product itself grew kind of complicated, right? And what really wound up happening was that most of these bigger companies, right, the hyperscalers, right, they had a fairly big data lake, which they hooked on to Presto. But then they had to hire a team of engineers to keep their Presto clusters up and running. And what my experience with that was that there was a fair amount of detailed research and learning that had to happen most of the time from reading the code to figure out how to make things work. So the main goal here, right, with this book is to compile a lot of the knowledge that we earned through late night troubleshooting and a whole bunch of battle scars that we accumulated with Presto, right, and make it more available and make it easier for people to consume, so that you don't have to, for example, wake up in the middle of the night with an outage and then post a question on Stack Overflow and then wait for an answer, hopefully, right? So the idea is that this book is going to be this compiled knowledge about Presto that we want to make available. And therefore, as part of our vision of bringing Presto to the masses, right, this was going to be the offering that, one of the offerings that does that. What this book is not explicitly, right, it's not a sequel, it's not a primer on how to write SQL or how to query databases. This is particularly about how to work with this piece of awesome technology called Presto, and how some of the most common configurations and some of the not so common configurations can be made and put together to provide a reliable, scalable deployment of interactive analytics. So I'm really excited to bring this guys to you. I know, as Ali said, it's been a long piece of work. I mean, we've been working on this for quite a while now, and I'm incredibly excited to see it finally ship shape and ready to be consumed.
Great. Awesome. Well, Angelica, Vivek, Tim, thank you so much for all your work on this. I think, again, this is an awesome asset. I dropped the link in there. So this is free. It's an IBM sponsored it. So they paid to have this done, and it's a really great community tool. So we appreciate that. All right. So if there are any questions, please jump in right now or put them in chat. We have the 3 authors here. This is a great time to ask. While you do that, Hope and Beinan, I'm going to pass it over to you to get us started with your session.
Sure, let me share my screen right now. Can you all see my screen?
Yep.
So would you like to wait for the questions, or you want just get started right now?
Go ahead and get started, and I'll just remind folks, questions, just put them into the chat. That's a great way to do it.
Okay, cool. I just want to get started right now. So today we are going to give a talk about a deep dive into caching in Presto. I believe this is a more specific topic than an overview of that O'Reilly Presto book that the author just mentioned. And we're very excited to be here. And first of all, allow me to introduce myself. I am Hope Wang. I am a developer advocate at Alluxio, and I've been spending my last 10 years working in the world of big data and AI. And I'm a software engineer by training, and I also contribute to open source projects such as Presto and Alluxio. Beinan?
Hi, I'm Beinan. I'm an engineer for Alluxio. I'm also the Presto DB committer and the TSC. I'm working on the Presto caching layer. I'm helping the companies like Uber, like Twitter, like TikTok to improve the performance of their Presto cluster.
Cool. Both of us are really excited to be here today to dive into the caching topic in Presto. And we have been working on this for a while now, if you're familiar with Alluxio. And during the time, like Beinan just mentioned, we work with Uber and Meta in their caching system. And we worked with them. We've learned a lot from their production use cases. So by the time we wrap up today's session, I hope you all have a deeper understanding of the different types of caching in Presto and why this is important to you and how you can enable them to work for you. So first, let's take a look at this number. So you might be curious about what this is, it's actually a 100 zettabytes of data. So that is the data projected to be stored in the cloud by 2025. And you can see it's growing exponentially. So it's a great pattern we see in different companies, like their data sets and their both structured and unstructured data are growing very fast. And however, only from our experience, only 10% of this data is actually used in a regular basis. I think we were very familiar with the term of hot data, and the number is actually from our collaboration with many open source users in the Presto community as well as Alluxio community, and we have the insights into their data access patterns. So the 10% is a typical pattern we see in the analytics workloads like Presto workloads. I want to take Uber as an example. What we have seen is only 1% of their disk space is used to handle half of their data. That is daily access. So with this in mind, we want to explore this question. And how can we identify the hot data and make the data more accessible and efficient to use? And this is very important because I know like you're all working on your Presto platform. So as we scale the platform to interact with very large data lakes, and we are exposing it to many users and tools who are using a Presto, and you might have tried all of the optimizations, and there is still a gap between the Presto and the data. So that is how the caching can come into play. So caching can bridge the gap that I just mentioned, and it's also a very common optimization technique to get the data locality, and because we have lesser trips to the storage. And here I have listed 3 values that caching provides. And the first is very obvious, is the performance. So caching can really significantly improve the performance of the queries by bringing the data locality with your Presto worker. So you will get a guaranteed low latency of reading the hot data, especially when your storage is remote. That performance gain will be more obvious. And the second is the reduced infrastructure cost, because caching can really reduce the amount of the data that needs to be transferred from your underlying storage system like S3. So for example, if you're using S3, like caching can reduce the number of the S3 get operations. So because S3 charges from the number of operations. So caching can reduce the operations, saving you the S3 storage costs. And if you are doing some cross-region data transfer, it will also reduce the egress cost. From what we've seen in the production, even if your Presto worker has a very small SSD disk, you can configure it with the cache, and we'll see very significant cost savings by using even a small cache. And the last but not least is about the network. So caching can help you to prevent the network congestion by reducing the number of requests through the network to the underlying storage system. So if you find your network is throttled or that is a bottleneck, and caching can really serve as a shield or a buffer to relieve the network among Presto workers and also the network between the workers and the data source. So overall, you can see caching has many benefits to speed up the query, save costs. And now I just want to hand it over to Beinan to give a deep dive into caching in Presto, because there are different kinds of caching in Presto, so you might not be familiar with all of them. And Beinan will provide you with that deep dive.
Thank you, Hope. Thank you, Hope. I will sharing the different kind of caching in the current Presto implementation. Hope, next page. Thank you. Yeah, in this talk, we shared 5 different kinds of cache. The first 2 we called metadata cache. So the first one is caching the result from the metadata store. The second one will caching the list file result from the name node with HDFS or the S3 service. So the first two will saving the query planning time and also save the metadata API cost. The last three, we will talk about the fragment result cache, the Alluxio SDK cache, this one called the local cache before, and the last one is the Alluxio distributed cache. So these three cache will cache the data, will cache the intermediate result, will cache the data, the data from the data source, like the Parquet file or RC file. So this will reduce the time of the table scan, because for most query, the table scan will be one of the major bottleneck. So if you can speed up the table scan, you may see a lot of performance gain. Next page, Hope. Thank you. So this is a chart talking about the position of this 5 kinds of cache. So about the first two, they are running in the Presto coordinator, because probably you already know the Presto coordinator is doing the planning. It will pass the SQL, generate the query plan. So in this case, the coordinator will fetch the result from something like a partition list from the higher meta store, and also it will try to call the name node or S3 service to get the list of the files, the data files actually. So they will cache this kind of result in the coordinator's memory. So when some similar query, they are hitting the same data set, they are using the same table or same data folders, they can just consume the cache. They can read cache the data in the cache directly to avoid the call to the name node or the HMS, because for the large scale Presto, sometimes the high meta store and also the HDF name node, probably there will be a bottleneck. And also if you're using the cloud storage, the list operation will be much more expensive than the read operation. And also, I think it's 10 times more expensive. And also, sometimes it will very slow if you have a large folder to list. So if you are seeing your planning time is a bottleneck, or maybe you are overloaded your name node, or you see a large bill on your S3, probably you can try this two cache. And on the worker side, because I'm talking about doing the real execution, the worker will do the real job of your SQL query. So in the workers, you can use the Alluxio SDK cache and also the fragment result cache to cache the data. So for these two caches, they will use the local disk, like the SSD or NVMe disk, to cache the data. So you can have a large amount cache capacity to use, because for most Presto queries, they will scan a lot of data. But still quite a few users, they have some concern because the local disk probably is still not that kind of big. Sometimes they cannot reach the really good cache rate because of the capacity. So they can use a separate cache cluster, we call the Alluxio system cache, and you can use it as a second layer cache. You can put your probably some of our users, they put all of their hard table, hard data into a Alluxio system cache. Then they can get a really good cache hit rate, and also they can reduce the data access to the cloud storage to save the cost. Okay, next page, Hope. Okay, let's go through each kind of this 5 cache one by one. So the first one is the metastore cache. As I mentioned, it's just the cache data from the high metastore, because the high metastore is something like a MySQL, whatever, maybe PostgreSQL, it's kind of RDMS backed service. So there might be some bottleneck because they may join multiple tables to give you the list of the partitions. So in this case, you can cache the list of partitions, you can cache the result of the information of the partition, and also you can specify a TTL, which means If the partition got updated, probably you add a new partition or change some existing partition. Then you can still get result after maybe the old data got evicted or invalidated because we have a TTL. So this kind of thing will have a guarantee about your data consistency. So so in this case, if you have a longer TTL, you can highly reduce the number of the call to the HMS. If you have a shorter TTL, which means you can have a better data consistency. Okay, next page. So the second one is the list file status. So because in the Hive meta store, for the Hive tables, I'm just talking about Hive tables here. So in the Hive meta store, they only keep the folder of your data. They won't give you a list of the files. But actually, the Presto, when they execute the query, they really need a full list of the files because they will send this file, the file name of the file path to the workers, and the worker will do the job. So here, the Presto coordinator will call the name node or the S3 metadata service to get the list of the files. That might be expensive. So you can enable the file status cache. The same thing, you can still specify a TTL, expire time. So this and also still the same thing. If you have a longer TTL, which means you can highly reduce the number of the API calls. If you have a shorter number, you can have a better data consistency. And for these two cache, the 1 and the 2, it can highly reduce the planning time because these two kind of call, sometimes it will be very time consuming. And also it can protect your HMS and your name node and save your cost. Okay, next page. So the third one is the fragment result cache. This one is caching the intermediate result of your queries. So probably you may have something like a aggregation on your queries. So in this case, you need if you can cache this part of result, you may see 10 times or even maybe hundreds of times speed up for this kind of query because the result you need just got cached. It's very similar configuration. You can still enable the cache by just this for configuration properties, and also you can put a TTL. So it's a very similar configuration, and you can specify a folder to which means which folder you would like to keep the data. And for the best cache hit rate, probably you need to put some node selection strategy. So here, we prefer use the soft affinity because which means for the same split with the same file will always go to the same worker. So if you have any aggregation on this split, so it will still on the same worker and it will hit the cache. Actually, in the code, I just checked the implementation. If there's no code selection strategy, the fragment cache, the fragment result cache won't won't kick in. Yeah, I think there might be some pros and cons because you might see some hot workers there. So that's why we are using soft affinity, which means if one worker is too busy to handle this kind of thing, because you may have some hot query, you may have some hot table, so the Presto coordinator will try to assign the same splits or the same subtask to another worker. For sure, you may see a lower cache hit rate, but it can avoid the hot workers in this case. Next page. I just see a question. I think I can answer it here. So Dennis is asking if is it still make sense to using Metastore cache for data lake, iceberg, and hoodie. So mostly for the data lakes in the high Metastore, it only keep just one entry. Where the table is. So something about the partition list and also the file list actually is maintained in the iceberg metadata. It's file based, so it's in some folder, maybe on S3, maybe on HDFS. So it would be a little bit, you know, you might not see a really good improvement here. Okay, so and also if you don't have a very stable Hamlet store, you can try to use the native what's the name? I mean, for the iceberg connector, you can make the metadata to store also in the file. You can just specify the folder, and it will load the metadata for each table from there. So you don't really need the Hamlet store for this tool. Okay, so for the Alluxio SDK cache, this one called local cache before. It's developed by the Meta's Presto team and Alluxio together. So it's just using the local disk of your Presto workers, because for the Presto, we just use the memory. We rarely use the disk. Even though we have something called a spelled data to disk, but don't open it, you will see a huge performance degradation there. So mostly we just use the memory to do all the calculation. But for most of the server settings, they still have a local SSD there. So somehow it's a waste of your resource. So in this case, you can enable the SDK cache on each worker for your table scan, or for your table scan, it will load the data from remote, right? So if you enable the SDK cache, it will cache the data into a local folder. So which means the next time you hit the same table, you hit the same file, it will just use the data we cached in the local disk to serve your table scan. I will go to some technical details in my later slides. And so this cache can highly reduce the table scan latency, and also it can reduce the number of API calls, because the API for your data reader, it will hit the S3 or something directly. Okay, next page. Yeah, I have to say the SDK cache has got battle tested for from Meta, Uber, Beinan, Newsbreak, Tencent, many internet giant companies are enable their our SDK cache in their production. Okay, next page. And by using the cache, mostly you can see the 50%. I think this data is collected from Uber. It's on their production cluster. So you can see the 50% of the read performance gain, and also reduce 10% of the data read traffic to HDFS. The 10% here means their entire HDFS, I think they have more than 10,000 HDFS nodes. They're not just serving Presto, they serve a lot of Spark and also other traffic. So the 10% here is the total traffic of their entire HDFS cluster. So it's large. It's a really large amount of data we saved. I mean, the really large traffic we saved in Uber. It saved a lot of costs. I think it's millions of US dollars per year. Okay, next page. And also, this one is the we call system cache, or Alluxio distributed cache. You can deploy a separate cluster. You can deploy the maybe 100 node or 1,000 node cache cluster with a large NVMe there. In case you don't have a really large NVMe disk on your Presto worker, so you can use this one to get a huge cache capacity. And if you have large cache capacity, mostly you will get a really good cache hit rate. So this one is really helpful. Okay, next page. Okay, here is the table talking about the scenario, the best practice of this 5 kind of cache. So mostly, as I mentioned, if you got some slow planning time, if you overloaded your name node, or the object store is suffering, or API is throttling about the least cost, use the first tool. And if you have a lot, hot query, or we call duplicate query, that scan the same table, they scan the same data. I think it's very common. Based on our previous research, we are seeing on the production, I think it's Twitter and Uber, most queries, I mean, more than 90% queries, they are hitting the same table or just 2 or 3 tables there. If you don't have a large local disk, you can also try our distributed cache, especially when you have some remote storage like a cross-region, cross-cloud data store there. You really need a large cache to save your cost and improve performance. Next page. Yes, but you know, I think that's true. The cache it's hard. It's really hard. So we need to pay a lot of attention about how to use the cache in the right way. Yeah, I will go to the technical details or the real technical challenge about implementing this kind of cache. Okay, next page. Next page. So the first one we call the soft affinity, as I mentioned. So for the previous page, okay, and so for the cache affinity, which means for the same file, the same space, it will always go to the same worker. So otherwise, the coordinator will do the scheduling randomly. It just picks random worker to do the job. So if you want a better cache hit rate, you need always assign the same file to the same worker. But the thing is, it may cause some worker too busy to handle the query because the Presto is still CPU bound application mostly. So if it's also by the CPU, we need to assign the worker to some, to some other workers. So we can have a better, overall, we can have a better performance. So there's just a balance between the IO and the CPU. So this algorithm is implemented by the Meta team and also got improved by Rong, I think last year or the year before last year. So now we really have a good result for this kind of thing. So feel free to try it. Mostly there won't got any negative impact. It just you can feel free to use it. Okay, next page. Yes, as I mentioned, Rong improved the affinity algorithm, and they are using the consistent hashing to select the workers. I won't go to the technical details, but just means if you have some worker up and down, so by using this consistent hashing algorithm, it can highly reduce the chance you rebuild the whole hash or you polluted your cache, something like that. So I think there's really something really good to try. You can check out the blog. There's some detailed configuration there. Okay, next page. And for the Alluxio SDK cache, there's something different from the other block store cache because we won't always cache the entire file. We only cache the most valuable part of each file. Because if you are talking about the columnar data format, like Parquet, like ORC, they are not something like read the very beginning to the very end. No such kind of thing. They are read from the very end. They are read from the footer of the file and check, okay, if we really need to scan this file or which portion of the file we need to scan, something like that. Okay, so in this case, for most file, we can just cache the footer. Then we have good knowledge because mostly, the query may just focus on maybe the last 2 weeks or maybe just a small portion of the data, even though you can partition your table by the datetime, there's still some query that cannot fully fill in this kind of partition keys. So by using this kind of page store cache, we can cache a lot of footers and can highly reduce, the number we touch from the HDFS because it just need to touch the footer we cached and say, okay, we don't need this file. Yeah, and which means you can use a very small amount of the cache space and cache a lot of files. Okay, next page. And here is the data consistency. Because I think that's the advantage of using Presto, because in the Presto, it will list the file in the coordinator. As I mentioned, we have a list file cache, right? So for each file, we will got the last modified time. And we will use this one. Actually, we will push down this value first from a coordinator to the workers. So the workers know the last modified time of each file. And in the Alluxio SDK cache, we will compare the last modified time from the coordinator and the last time we stored in the cache. If it's not matched, which means we are keeping the stale data, which means the data is too old to use. So we do the data eviction. So which means if the list file status, the result of the list file status is fresh, you won't got the old data, you won't got the stale data. You will always got the fresh data from the cache. Okay, next page. Then I will share some ongoing work. Okay, no other question. Okay. So first one is the semantic cache. As I mentioned, because most users are using ORC and Parquet. So they have some internal file structure. They have a footer, they have index, they have row groups. So we don't really need something like we cache the entire file, or we cache the file in each 1 megabyte. We can, based on structure of the file, we only cache the most hot section in this file. We can reduce the actually it can be reduced the read amplification to 0. And also they can reduce some of the CPU usage, because we already know the structure. We can reduce some of the parsing work. We try some of the idea in Meta. We are seeing 8% of less CPU usage there. It's a really good result. Okay, the next page. And also now the current implementation is we call it the heap cache, because they are using the JVM memory to store the metadata. The data is still on the disk, but for the metadata is still in the Java's memory, because the caching probably is some anti-pattern for JVM's GC algorithm, because you may keep the reference too long, so it cannot be collected by the young GC. So we are seeing a lot of pressure to the JVM. So in this case, we are making a pure native cache implementation. We can see the GPU, the GC pressure is super low. I think it's more than 1 time lower than the heap cache, and also the GC post time is much lower than before. You can take a look at this result. The left side is actually the heap cache, and the right side is the off heap cache, and also you can see the object allocation there. It's super low. Okay, next page. Yeah, there's also a blog authored by Hope and me. It's published in the info world. You can take a look. It contains more technical details and configurations there. Yes, I think that's all of today. Any questions?
Thank you, Beinan. Thank you, Hope. I think you did get a few questions, but you answered them, which is great. So I know we're coming up on time. If there are any questions, feel free to put them in the chat, or I know Hope is definitely in our Presto Slack channel. Beinan, I believe you are too. Great place. If you have specific questions around caching, around Alluxio for Presto, check them, DM them or reach out to them in Slack channel. I think you guys are there. All right, folks. So I just posted the link for PrestoCon. If you're in the area, we'd love to have you. It's going to be an awesome event. Thank you to all of our speakers. I think Vivek's still here. Angelica, thank you so much. And obviously, Beinan and Hope, appreciate it. This was an awesome session. We covered a lot, so appreciate everybody sticking through with us. We'll be doing these every month, so keep an eye out. And again, highly recommend joining the Meetup group near where you live. We'll be doing more in-person stuff. So if you join where you live, you'll get all the details on those. All right, this was recorded. You'll get a link to the recording as soon as it's ready. And I think we're good. So thanks again, folks. We'll see you next time. Cheers.
Thank you.